Alright guys, my name is Brad Jose. First, we're going to look at drag force on various bodies. The first object is a circle cylinder. Second object is a square prism. And the third object is a airfoil. Let's get into this. Now, as we look at the circular cylinder, as we start from the top, the total drag force will be the same because the theta is 0. Now, as we rotate it, when we get to eventually 180 degrees, it will actually be the exact same as the force of drag here, but negative, just because the pressure difference, and there's only one pressure tap. And we don't need to go past 180 because then the symmetry and the forces will be exactly the same. Next will be the square prism. Now, the square prism, we're only going to do it at 0 degrees, an increment of 15s until we eventually get to 45. The reason being is because once we get to 45 degrees and then past that, since it's the same on every single side, there's no reason to do it because the pressure will be exactly the same. So the force of drag will all be the same, making the coefficient the same. Now, lastly, we have an airfoil. Now, what's cool about an airfoil, you can think of it as a plane wing. As you increase the angle, you're going to have a lift force that's created with the airfoil. But then once you get to a certain angle of attack, as you increase it, it'll actually create a stall within the system. And then that's really cool. We can analyze airfoils almost like how a plane does a takeoff and stays in the air, producing lift. Now with the square prism, at 0 degrees, the force of drag is 0.93 newtons, which is higher than the force of drag at 45 degrees of the square prism, which is at 0.77 newtons. Now the coefficients of drag should be the same because on the square prism, it is equal on every single side. So that meaning no matter what the rotation, the coefficient of drag should be the same, but on the angle it changes because of the theta value. Now, with the prism being symmetrical, you have a fixed value of the coefficient of drag. Now, with the cylinder, the coefficient of drag will change. It will actually get lower than the prism because then the orientation of the theta value will actually change in itself, then lowering the force of drag upon the system of a cylinder compared to the system of a prism. And then with an airfoil, the airfoil will usually stall around 26 degrees, but then it will regain its lift around 11 degrees. Then with a 30-foot flagpole and a speed of 50 miles per hour air, we will get a total drag force of 63.9 pound force. And then for the bending moment, we'll get a bending moment of 958 foot-pound force. And then when calculating the Reynolds number, we will get 1.4 times 10 to the 7th, so in the realm of 10 to the 7th, while the experiment was only in the realm of 10 to the 4th, which was around 55,000. Alright guys, that's all I have for you, so I hope you guys have a great day.